More than 6 billion people in the world consume milk and milk products. That's roughly 75% of the world's population. In just the US, a whopping 100 billion liters of milk is produced each year. But have you ever looked at the glass of milk on your breakfast table and wondered what goes on behind the scenes? The process begins on dairy farms, where cows are raised specifically for milk production. These cows are kept in clean and well-maintained environments, and the farmers take a lot of care in making sure that their cows remain stress-free, since that ultimately affects their milk production. Dairy cows are usually milked 2 or 3 times a day using milking machines. The average cow can produce anywhere from 25 to 35 liters of milk every day. Milking machines are designed to be gentle and efficient, ensuring the well-being of the cows. In modern farms, several milking machines are attached to a rotary parlor, which can accommodate anywhere from 20 to 80 cows at the same time. The raw milk flows through stainless steel or glass pipes to a refrigerated bulk milk tank where it is cooled to about 4 degrees centigrade. After the cows have been milked, a refrigerated bulk tank truck makes collections from dairy farms and delivers them to the processing facilities. Before pumping the milk from each farm's tank, the driver collects a sample and checks the flavor and temperature and records the volume. Because milk is a perishable commodity, dairy farms and processing facilities are usually in close distance to one another. At the milk processing plant, the milk in the truck is weighed and pumped into refrigerated tanks in the plant through flexible stainless steel or plastic hoses. The cold raw milk passes through either a clarifier or a separator, which spins the milk through a series of conical discs inside an enclosure. A clarifier removes debris, some bacteria, and any sediment that may be present in the raw milk. A separator performs the same task but also separates the heavier milk fat from the lighter milk to produce both cream and skim milk. Some processing plants use a standardizer clarifier, which regulates the amount of milk fat content in the milk by removing only the excess fat. The excess milk fat is drawn off and processed into cream or butter. Next up, the milk is fortified, which involves the addition of specific minerals and vitamins to enhance its nutritional content. This process is typically done to address nutrient deficiencies or to meet specific dietary requirements. Usually, vitamins A and D are added to the milk with the help of a peristaltic pump, which automatically dispenses the correct amount of vitamin concentrate into the flow of milk. The milk, either whole milk, skim milk, or standardized milk, is piped into a pasteurizer to kill any bacteria. The process was discovered by Louis Pasteur of France, who actually developed it to kill the bacteria in wine to prevent it from turning into vinegar. Later, it was found that the process could be used to kill harmful bacteria in not just wine, but a variety of food products. There are several methods used to pasteurize milk. The most common is called the high-temperature, short-time HTST process, in which the milk is heated as it flows through the pasteurizer continuously. Whole milk, skim milk, and standardized milk must be heated to 72 degrees Celsius for 15 seconds. Other milk products have different time and temperature requirements. The hot milk passes through a long pipe whose length and diameter are sized, so that it takes the liquid exactly 15 seconds to pass from one end to the other. A temperature sensor at the end of the pipe diverts the milk back to the inlet for reprocessing if the temperature has fallen below the required standard. In raw milk, the fat content is naturally present in the form of globules. Over time, these fat globules can rise to the surface, causing cream separation, so milk is homogenized to reduce the size of the remaining milk fat particles. This prevents the milk fat from separating and floating to the surface as cream. It also ensures that the milk fat will be evenly distributed through the milk. The hot milk from the pasteurizer is pressurized to 2,500 to 3,000 psi, 17,200 to 20,700 kPa by a multiple cylinder piston pump and is forced through very small passages in an adjustable valve. The shearing effect of being forced through the tiny openings breaks down the fat particles into the proper size. The milk is then quickly cooled to 4 degrees Celsius to avoid harming its taste. In the production of powdered milk, there's one extra step involved before the packaging process. First, the milk is concentrated to increase its solid contents. This is typically achieved by evaporating a significant percentage of the water, leaving behind a more concentrated liquid. After concentration, the milk concentrate is then subjected to spray drying, which is the process that transforms the concentrated liquid into powdered milk. The concentrated milk is first fed into a chamber where it is atomized, meaning it is broken down into small droplets. This is typically achieved by spraying the liquid through a nozzle. The droplets are then introduced into a drying chamber. Hot air is simultaneously blown into the chamber, causing the water content in the droplets to evaporate rapidly. As the water evaporates, the remaining milk solids form tiny dry particles. These particles fall to the bottom of the chamber, and the dried powder is collected. The processed milk is then packaged into various containers, such as cartons, bottles, or jars in the case of powdered milk. One of the first glass milk bottles was patented in 1884 by Dr. Henry Thatcher, who came up with the idea after seeing a milkman making deliveries from an open bucket, into which a child's filthy rag doll had accidentally fallen. By 1889, Thatcher's common sense milk jar had become an industry standard. Packaging is done under strict hygiene standards to prevent contamination. Throughout the production process, rigorous quality control measures are implemented. This includes testing for bacterial contamination, checking for proper pasteurization, and ensuring the milk meets regulatory standards for various components. This is important because the milk must comply with these standards to be classified as Grade A milk, which is about 90% of the milk produced in the United States. If the milk somehow doesn't fall on these stringent standards and receives a Grade B, it can only be used in the production of certain cheeses, which undergo further processing. The gold standard in sanitary conditions is certified milk, which is sold at a higher price than Grade A milk. To ensure sanitary conditions, the inner surfaces of the process equipment and piping system are cleaned once a day. Almost all the equipment and piping used in the processing plant and on the farm are made from stainless steel. Highly automated clean-in-place systems are incorporated into this equipment that allows solvents to be run through the system and then flushed clean. This is done at a time between normal influx of milk from the farms. Once packaged, the milk is distributed to retailers through a cold chain to maintain its freshness. Refrigerated trucks are commonly used to transport milk to ensure it remains at the appropriate temperature. The milk reaches retail outlets, where customers can purchase it for consumption. Commercially produced milk is available in various forms, including whole milk, skim milk, 2% milk, and specialty products like flavored milk or lactose-free milk. That was all about how milk is produced, from its humble beginnings in a dairy farm to the aisles of grocery stores. If you want to know about how ice cream is made, check out this video.